Hello everyone, let's look at this factoring problem here. We have two terms and we usually, to deal with a factoring problem, we try to factor out the greatest common factor, what we call a GCF. And so maybe there are more stuff that we can do after factoring out the GCF, but we usually cannot do any of those until we have factored out the GCF because usually the GCF will be hiding the true form of the expression. And so now let's get started on this. Okay, so we deal with the numbers first. We have 15 and then we also have negative 10. And we want to try to figure out a number that goes into both 15 and 10 other than 1. And there is such number which is 5. So we can factor out the 5, and pull out the 5 from the 15 and then the negative 10 so that we have two numbers that are relatively prime as the coefficients of the two terms here. So let's do that. Okay, so the GCF would be yeah, so we can actually just write it down first, right? So we can write it down, and then we have what? We have 5. Okay, so 5 works. And then now what about the other stuff? Let's look at the variables here one by one. So let's look at the x's. We have x squared in the first term, and then there was an x to the just x, right? And when we do not put an exponent here, we assume that exponent is 1. So we actually put that there. And so if you look at the x's, then there are two copies of the x right here, and then there is only one copy of the x here. And we want to factor out the same amount of x's from both terms right here, right? And the maximum number of copies of x's that we can factor out would just be just one copy, because if you factor out two copies, then there is not enough copies for you to factor it here. So you can only factor out just one copy from both terms. So our greatest common factor will also have an x in it. Okay, now what about the y? Regarding the y, we have y squared in the first term, and then there is a y to the third in the second term. So if you look at this, we can factor out at least 2 copies from both terms. And then now the question is, can we factor out 3 copies? Yes, from this second term here, but no for this first term, right? We do not have enough copies. So the maximum number of copies of the y's that we can factor out would be y squared, will be 2 copies. Okay, so we get y squared. So now our GCF is actually 5xy squared, and then now we can start doing this problem. Okay, so let's put down the equal sign, and then we will put the GCF first. Okay, so we put that here. So 5xy squared. Then now we can start putting the parentheses. Okay, so now just keep in mind that once you factor the GCF, you should still have the same amount of terms that are inside the parentheses. So if the original expression has 2 terms, we should still have 2 terms in here. And then there was the minus sign that will come down, right? Because we did not factor out any negative numbers. Okay, so maybe the x is negative, but there was no negative sign involved, and so we are not changing the sign. Okay, so what do we have here? We need to figure out what goes right here, which is our first term after we factor out the GCF. And we want to think about what number times 5 will give us the 15. So that number should be 3. Okay, so we have the 3 here. And then now what about the other stuff? Now, if you just distribute this 5xy squared to this 3, then you are going to get 15 and then x and then y squared. But that's not what we have here in the original expression. And so let's think about this. Something times x will give you x squared. And that's just one copy of x here. And then there are 2 copies. So we need 1 copy so that when we have 1 copy right here, x times x will give us the x squared. So let's put 1 more copy here. This is x. Okay, what about the y? The y, there was something, what, right? Y to the some power times y squared will give us the y squared. And actually, we do have the y squared that's completely pulled out from whatever term that we have here. So there are no more y's in here. So we just have 3x as the first term. Okay, so our first term is done. And then now we put down the minus sign. And then what's next? The second term. So let's think about this. Negative something times 5 will give us negative 10. And what is that something? That something must be negative 2. So we have 2 right here. Okay, so that's the 2. And then something times x will give us x to the first power. And that's also x to the first power, so we completely pull out the x already. So there are no more x's in the second term, so no more x's. And then what about the y? Something times y squared will give us y cubed. And so we just need one copy of the y right here. So that when we have y to the first power, right, we didn't put a 1 here, but then that's assumed to be y to the first power. And then times y to the second power will give us y to the third power. So that will work. And actually, we don't really need to put the 1 here. And so I can erase the one from the original expression as well. Okay, so we get the 2y right here. And then now we are done with both terms. We still have 2 terms in here. And then now we can close the parentheses. Okay, so let me draw it again. I think it looks too bad. Okay, so that's that. And actually, as you can see here, that's a linear expression. There is nothing more that we can do to factor from here. So we're done with this problem. And this problem is really just for demonstrating how to factor the greatest common factor from 2 terms. Or actually from multiple terms, the idea is the same. So if you have 3 terms here, then you are going to get 3 terms inside the pair of parentheses. Okay, so lastly, if you have time, then you actually just want to just do a quick check to make sure that the calculation is correct. So let's quickly just check. So 3 times 5, we get a 15. X times x, we get the x square, and then there is no y, and then we have the y square. Okay, so that's good. And then now what about this 2y here? The negative sign will stay. And then we have the 2 times the 5 will give us the 10. And then there was no x here, then this x will give us this x, so that works. And then we also have y here. Y times y squared will give us y cubed, so everything works. Okay, so that's it for this problem. Thank you for watching. See you next time.